Example 6, finding extreme values on a closed interval. In part A, we're going to use a graphing device to estimate the absolute minimum and maximum values of the function f of x, which is equal to x minus 2 times the sine of x, where x is in between 0 and 2 pi. So let's go ahead and graph this. So we're going to graph our function. We're going to graph x minus 2 times the sine of x. Okay, and then we're going to put in our endpoints. So we know there's going to be 0, and then less than or equal to x, which is less than or equal to 2, and then we're going to write pi. And therefore, we're going to end the brace there. So now we can see what our points are on our graph. So let's go ahead and do that. So we're going to go ahead and click on that point there. There's that point. You can see that point, and then this point here as well. And so since it's not showing there, what we can do is we can just go ahead and write it as an ordered pair. We can write, okay, well, we're going to put 2 pi as the x value, and then we can just write the output to be, instead of x, it's going to be 2 pi minus 2 times the sine of 2 pi. And therefore now it labels the point on the graph. So there is that point, and then we can go ahead and label our points. So this is our closed interval, and let's go ahead and copy that. Okay, so what do we know? Well, we know that we have a value that has a minimum right now. So that minimum is at pi over 3. So this absolute and local minimum, okay, is at the value of when x is equal to, okay, so pi over 3, if we run out to 2 decimal places, that means that x is going to be 1.05, where the y value is negative 0.685. Okay, and then over here, we can see that this is an absolute and local maximum. Okay, 5 pi over 3 reduces to 5.24. So that means that x is equal to 5.24, and the y value is rounded to 2 decimal places at 6.97. Okay, now let's summarize what we just did. Okay, so if we summarize, we can see that when we graph the function above in the viewing rectangle between 0 and 2 pi and negative 1 to 8, by moving the cursor closer to the maximum point, we see that the y-coordinates don't change very much in the vicinity of the maximum. However, the absolute maximum value is about 6.97, and it occurs when x is approximately 5.2. Now similarly, by moving the cursor close to the minimum point, we see that the absolute minimum value is about negative 0.68, and it occurs when x is approximately 1.0. So it is possible to get more accurate estimates by zooming in toward the maximum minimum points, but instead we're going to use calculus in part B. Okay, now in part B, we want us to use calculus to find the exact minimum and maximum values. So let's go ahead and do that. So what we want to do is first take a look at our function. We know that our function f of x is equal to x minus 2 times the sine of x. Okay, now what we want to do is we want to take the derivative of this function. So if we take the derivative of this function, that means derivative of x is 1 minus the derivative of 2 sine of x is 2 times the cosine of x. Okay, now in step 3, we're going to let the derivative 1 minus 2 times the cosine of x, and we're going to set that equal to 0. So let's go ahead and subtract 1 to both sides. We get negative 2 times the cosine of x, which is equal to negative 1. Divide both sides by -2. Therefore, the cosine of x is going to equal positive 1/2. And so we want to find out, okay, when does x is going to equal the cosine inverse of 1/2. Okay, so let's take a look at our x and y axis here. Okay, so we know that we're looking for the angle of when the cosine of x is equal to 1/2, or when x is equal to the cosine inverse of 1/2. So when do we know it's equal to 1/2? Well, we know that that's when the angle we have here is pi over 3. Okay, which means that we have a side of 1 here. Okay, and the hypotenuse is 2. So what does that tell us? Well, that tells us that we have a squared plus b squared equals c squared. So that's 1 squared plus b squared, which is equal to 2 squared. So that is 1 plus b squared, which is equal to 4. Subtract 1 to both sides, and we get 3, and therefore b is going to equal the square root of 3. Okay? And so then we also know that if we have our right triangle on this side as well, this represents -1, this represents 2, and then this is the square root of 3. Okay, but what we're looking for is we're looking for that next angle here that's going to be 5/3. So therefore, this is 5 pi over 3. Okay, and what that does is that gives us this angle here, which is the same angle. And so here we have the hypotenuse of 2, and this is negative square root of 3. And so what does that tell us? That these are the two angles, pi over 3 and 5 pi over 3, that we can use. So therefore that tells us that x is equal to the two angles, pi over 3 and 5 pi over 3. Okay, so now we want to be able to then determine, okay, what are the outputs? So if we know that this is pi over 3 and this is 5 pi over 3, so now using our function f of x, which is equal to x minus the sine of x, okay, we first want to find out, okay, what is f of pi over 3? Well, that's equal to pi over 3 minus the sine of pi over 3. And that should be 2 here, so that's 2 times the sine of pi over 3. And so we know that this becomes pi over 3 minus 2 times, well, the sine of pi over 3 is the square root of 3 over 2. And so that gives us pi over 3 minus the square root of 3. Okay, then we're going to find f of 5 pi over 3. And so that's equal to 5 pi over 3 minus 2 times the sine of 5 pi over 3. So we have 5 pi over 3 minus 2. The sine of 5 pi over 3 is negative square root of 3 over 2. So this ends up giving us 5 pi over 3 minus or plus the square root of 3. Okay, so that means that our two values we have for x was pi over 3, and then the y value is pi over 3 minus the square root of 3, and then we have 5 pi over 3, and that's 5 pi over 3 plus the square root of 3. So if we put this into our calculator, then we end up getting pi over 3, which is approximately 1.05, like we found on the graph, and pi over 3 minus the square root of 3 ends up giving us negative 0.68. Okay, and then 5 pi over 3 gives us approximately 5.24 for the x value. And then if we take 5 pi over 3 and we then add the square root of 3, then we end up getting 6.97 for the y value. So we can see here that it matches what we have for our minimum and our maximum. Okay. Now we also want to determine what's happening here. Well, what happens if we plug in 0? Okay, so if we plug in 0, f of 0, okay, that's going to be 0 minus 2 times the sine of 0, which gives us 0. And if we plug in 2 pi, that's 2 pi minus the sine, 2 times the sine of 2 pi, which ends up giving us 2 pi. And so therefore that confirms these numbers, 0, 0, and 2 pi and 2 pi. So therefore there is our using calculus to find the exact minimum and maximum values. And so again, keep in mind that here represents the horizontal tangents.